Hello, this is Shinru. In this video, I'm going to take a look at question 338, counting bits. So this question is a part of a math question. So for a math question, there is always an equation or a special rule that helps you to solve the question instead of um, solving the question by brute force. So here, for this question, let's take a look at this question first. So, given a non-negative integer number num, for every number I in this range, in the range that the I is between 0 and the num, and we have to calculate the number of ones in the binary representation and return them as an array. So there was a question that asked us how to calculate the number of ones. So for a single number, that's how we are going to do that for a single number is we are going to first define. Okay, I'm going to write it here. So I'm going to wrap it around with this, and so to find the number of 1 bits for a single number is we first define a count, and then we do the while loop. While the number is not equals to 0, the number will keep equals to the number and number minus 1. This statement will always remove 1 from remove one bit from the num. So it will always remove 1 bit from the num, and then we use this count to count the times that we need to do this operation to remove ones from the num, and until the num becomes 0. So after we get the count, then that count is the number of 1 bit in that single number. But in this case, we can define a function. We can make it a function, and then we can do a for loop to all those numbers and use this function to get the number of ones, but that will exceed the time limit. So that is not what we are looking for. So what we are looking for is for multiple numbers, what we are looking for is to find a pattern between those numbers, because as you can see, there is a pattern. So mathematically, if the number is an odd number, then the number will always be the previous number plus 1. And if the number is an even number, then the number always will be the number divided 2. And if the number is a number has square root, then the number, so if a number is another number's square, and then this number will have one as the number of the ones. So following these rules, we can use a for loop and use these 3 rules to get to use this pattern to get the entire list between this range. So what we are going to do is first we are going to create a result array, and this array we are going to input the number we're going to push 0 into the array. So we initialize this array with 0, with the length of the nums, and the second step is we are going to traversing through the num. Oh, sorry, we are not going to, because the input is num, so we're going to create this array, initialize it with 0, and the second part is we are going to actually traversing through this array, and based on the number that it trying to find the number of 1 bits. Based on the number, we use these rules we set up here, and we process this array and get the result array we want. So how we are going to do it first, let's consider the condition. If I is another number's square, then what we will do is if I and I minus 1 is equals to 0, then this result of I will initialize it as 1, and if the I is a odd number, then what we will do is we will find I minus 1 equals to, result of I equals to result of I minus 1 plus 1. And if this I is an even number, then what we will do is find out the number of I, find out the position I divide 2, and that will be the number of 1 bit for the number I. And so as you can see, we just completely follow these rules, and we process this array. So one thing worth noticing is that you have to put this condition first, because if you don't put this condition first, then the process will start from an array with all every number is 0, then that won't work. So you have to first put the number that has a square root first. So after this process, let's take a look at the result. So the result will be what we want. Exactly.